Hey everyone, we are live and welcome to Monday Night CAD. What a Monday it was. I was a bit sick actually. I took a sick day out of work and I wasn't gonna make it today, but I kind of feel better now, so let's see. I might be a bit off, but I guess that's fine. And before we actually start, I wanted to show you the lure that we did on Friday because I just finished it. I just finished like printing and assembling and painting it. So this is an unpainted version of the lure. I have one back there. Where is it? There, being cured at the moment. And yeah, that's the lure. Is it in focus? Now it's in focus. And it's kind of nice. Like this looked very ugly when I was designing it, but when I printed it, it looks so much better. And just in case, whoops, sorry, I have this just in case. But anyways, it's Monday Night CAD, not Friday night Lure Lab, so we're gonna do some CAD work. And unfortunately, last time we didn't finish the tackle box, so we're kind of stuck with it at the moment. So we have to finish it today. Hopefully this shouldn't take long. And then, I don't know, we can do something else. I can answer your questions, or I have a different lens on today. Let's see if this is better or worse. Anyways, back to CAD. So, just kind of a reminder where we left last time. So we've done these hinges, and they are completely parametric. So we can actually come here, change the number of hinges, spacing, thickness, and everything. And it's working well. Like I can set this to 1 now. And we're gonna have only 1 hinge. Let's get it back to 2. Now, I'm not super happy with these balls, to be honest. I think they should go back a bit. So maybe we can fix that real quick. Let's see, box. I think it's this sphere. Yeah. Let's see if we can get it back by some offset, and we need to define that offset. So here we have hinge ball diameter, hinge ball thickness, or hinge thickness. Let's put it here. Hinge ball offset. And the diameter is 5. Let's try 1 for now and see how it looks. So now I think it's in the Y direction, so we add the hinge. Total height, no. Is it the X? We already have a hinge ball offset? Oh wait, what was this? Hinge ball offset. Okay. This was the distance between this line and the ball. No, we needed something else. Oh, okay, we're doing this on a datum plane. So we want to check that datum plane. That's going to be tricky, because we're using that datum plane to do the pad. And we are attaching. Oh, it doesn't have to be tricky. We can just go here in the Z direction. Yeah. Okay. So first, this needs a different name. So let's call it, whoops. let's call this hinge ball, I don't know, offset 2 for now. I don't want to waste too much time on it. What's going on? I'm still not used to this keyboard. Hinge ball offset 2. I'll change the name later, don't worry. So do we need to go in a positive? No, negative direction. So this is gonna be lead params dot hinge ball offset 2. And in the negative. Okay, I think we need to do more changes. Let's see. Yeah, we have another sphere. And this one has to go in the positive direction. So let params dot hinge ball offset 2. Okay, and now we can control this from here, like 0.5 should go out more. Let's keep it at 1. Okay, so we fixed the box, but we still need to fix the lid, because also here we have this. And let's see, this is the sphere. Okay, and we need to go in the Z direction, in the positive direction, by let params dot hinge ball offset 2. Okay, and we have another sphere, this one, in the Z direction. Which direction is this? Y, no, 0. Oh, that's interesting. Let's see if I add 1 here, what's gonna happen? Okay, so we need to remove. So minus let params dot hinge ball offset 2. And now we should have same offset for both of them. Okay, so this is fixed now. And let me grab 1 second. I had to grab this for reference. Okay. So we need to model multiple things. Let me get it out here. So we have this, the what is it called? The snap lock. And then we also need to model these 2 parts, one at the lid and one at the box. And yeah, I guess this is the last thing that we need to do in this box. And maybe if we have some extra time, maybe we can make this so we can add more sections here, maybe horizontally or vertically. I don't know, we'll see. But for now, let's focus on the snap lock. And we are gonna do, wait. So let's see how we're gonna do this, because this has a specific shape. What is the best way to do it? So it looks like at the top it snaps in place using the same ball mechanism we use on the other side. So maybe we can model this first, and then we can see how to do the rest. Yeah. Okay, so if you look at this, you can see that it goes down, then it has this like triangle shape and then it continues down. What we can do is we can model this section. So just a rectangle. And then later on we can add these because we need some parameters for them once we start modeling this part. So let's do that. Lid parameter. Maybe we can reuse the hinge spacing. No, let's create a new spreadsheet for this. And I'm gonna call this the snap lock. And we can add some stuff here. So let's define some things for this lock, like for example the width, height, and what else do we need? Let's see. Let's start with the width. Why am I at 4? Let's do here width. Put random numbers. Height, let's say 15 for example. And maybe, is it centered? Let's see. It's not centered, but do we need to define these? Or do we use the height of the lid, for example, to determine? Let's see. Okay, we'll see. Maybe we can do a tolerance here. Tolerance 0.2, for example. And now let's assign these an alias. Tolerance, this is height. Width. Oh man, the weather is super hot today. Let me remove this. Okay, let me turn off the music. Actually, I forgot to do that. Yeah, so width, height, and tolerance. Let's do is thickness. Let's say 5 mil. Let's add an alias for the thickness. I think these are enough to get us at least started. So I guess we need to reuse the number of hinges, or do we create a new param for this, like number of locks? Let's create a new one. Oh, come on. Number of locks, let's say 2. And add an alias. What else do we need? Let's calculate the total lock width. So the total lock width will be basically the width of this, and then we need some tolerance from here, and yeah, and the thickness, this thickness on each side, so multiplied by 2. So the total lock width is going to be equal to width plus tolerance times 2, because we need one on each side, plus thickness times 2. And oh, I forgot. Come on. Forgot to click enter. Width plus tolerance times 2 plus thickness times 2. Okay, 20.4 is going to be the total width of the lock. And what else do we need? We need the spacing between locks, similar to what we did here, spacing between hinges. And we can do the same calculation actually. So no need to redo it. I'm going to copy it. Come here and say spacing between locks is going to be equal to, okay, already added the equal. So the total length of the tackle box minus the border radius multiplied by 2, and then we need the total lock width here, total lock width, and number of locks instead of hinges. So a number of, did I write it this way? I think. And then we divide by number of locks plus 1. So that's going to be 46.7. give it an alias. So now we have the spacing, we have the total lock width, we have the thickness. We can start doing some stuff. Let's save. Okay, so we can start on the lid or the box, it doesn't matter. Let's do the lid, and we need to make it as an active body. And you can confirm this by the color here. Okay, and we need to start from somewhere, which is the border radius plus the spacing that we calculated here, spacing between locks. So let's show the origin just to see where we are. Okay, this is the front. Okay, so this is the XZ plane. I'm gonna attach a datum plane to it, and then I'm gonna move it in the Z direction. Apparently it's negative, so we need to go this way. And how much do we want to go? It's minus tackle box dot border radius minus what did I name it? Snap lock? Yeah, snap lock dot spacing between locks. Okay, so we're gonna start from this plane right here. Gonna create a sketch, and I'm gonna make it a fairly simple sketch. Oh, okay, we need to define, yeah, that's fine. We need to do some, let's hide the sketch. So we need to define some variables, some constraints, because we are not at the center. Show the section view. Okay, so this is where it starts. I'm gonna hide the box just so we focus on the lid. And I'm thinking, why not we make the entire, yeah, the entire length, then it's gonna be more printable. So let's click this dot and this line and constraint point into object. Interesting, nothing happened. Okay, now it worked. Okay, and now we need to constrain the horizontal distance between the origin and one of these dots. Let's do this one, and this is gonna be the tackle box dot. Is it total width? Let's see. I think it is. Yeah, because this is gonna be the width, and this is the length. Okay, yeah, it's total width. And now we need. Okay, we need the height of the lid. We already know that. So this is gonna be the lid params dot not height, depth, total depth. Okay, and the only thing that we're missing at the moment is how much do we go outwards, and we didn't define that, so we might actually need to do it. Snap lock. So we have the width and the height of the lock, but we don't have the depth of it. So yeah, let's call it thickness. Oh wait, thickness. Okay, the naming here is gonna be a bit confusing. So let's assume the thickness is the thickness of the lock itself, and let's call the hinge thickness, for example, here, or the hinge width. Okay, hinge width. Let's say this is 6. So now we need to know how much do we go outwards. So we know the thickness, but is it like exactly? Let me check. No, we need to add a bit more. they have like a mill more, and this makes sense because you want to snap in place and stay there. And yeah, so let's add here extra thickness. Let's say 1 for now. I need to document these. Ooh, I closed the spreadsheet. Okay, so the total thickness, is going to be equal to thickness. Oh, come on. Okay, plus the extra thickness. And do we need tolerance? I don't think we do. Yeah, so we need the total thickness here. Snaplock dot total thickness. Okay, this should be fine. Close it. And now we can pad, but remember that we need to pad this way. So because this where we started here, this is the beginning of the snap block. So we need to pad reverse. Yeah. And how much do we need to pad? This is in snap block dot total thickness, or no, it's the lock width. Interesting. What did I call it? Is it width? Hinge width. Yeah. Okay. So this is one of them. And now we need to move it this way. Or we need to create a pattern. And to do that, we're gonna use the lattice 2 workbench to create an array, similar to what we did on this side. So we model it for once, and then we use an array to model it twice. And now if we change the number of locks, it will update automatically. So how do we do this? We are going to create a linear array, and now we need to move this linear array here, basically. So in the we need to change the direction first to go in the y direction. So here y, we set it to 1, x we set it to 0, and now we can move it in the placement position, and we need to move it in the x direction by the total width, and that is tackle box dot total width. Should be here, yeah. And now we need to move it in the y direction by the same amount that we moved this sketch, which is tackle box dot border radius plus the snap lock dot what was it, spacing between locks. And now it should be right here. Okay, so now to fix the pattern, we're gonna use the step n. And then what is the step? The step is going to be the spacing. So what do we call it? Snaplock dot spacing between locks. And the count is the snaplock dot number of locks. Okay. So now if we come here and change the number of locks to 3, it should update. But there's something wrong. Wait. Step on span end. Why do we have a span end? Okay, I know this does nothing, so it's fine. There's definitely something wrong. This step is 30.9. Spacing between hinges, it's 40. Why is the step 30.9? Spacing between locks, oh, it's here. Oh, okay, spacing between locks is actually 30.95, that's fine. It is the total lock width. Very interesting. Wait. Lattice pattern, linear array. So what did we use here? Should be just the spacing. Oh, spacing plus the total with hinge width. Okay. Yeah, my bad. That makes sense actually. So it's gonna be, so each step we need the spacing, and we also need to add to it the snap lock dot total lock width. Okay, now it's working. So number of locks, let's do 2. And now the spacing will change and everything will update. Brilliant. I told you I'm gonna be a bit off today because I'm a bit sick. So let's click the pad, control click the linear array, and then in part design we can create a pattern. So now we need to do the same for the other part. So we have this datum plane. We can attach another plane to it. So for the reference, select this plane. And now in the Z direction, I believe, I need to go by snap lock. Okay. So this is at the beginning of the hinge. We want to go to the end. So we want to go by total lock width. And this is negative. So minus snap lock dot total lock width. And now we're at the end. So now, because we are at the end, we need to create a sketch here and we need to pad this way. But it's weird that total lock width, wait, it's the width plus tolerance times 2. Oh, okay, that's why the lock width is a bit weird. I didn't include a spacing. What did I call it? The hinge spacing. I didn't add one for the locks, so let's add one for the locks. Let's use 5 for now, hinge spacing. And the total lock width should also include the hinge spacing. Oh wait, we don't need hinge spacing here. Oh my god, I'm totally off today. We don't need, because we have a width. The width is 10. So once I'm done with this, we should be left with 10. Let's see, let's hide this and hide this and create a sketch. Okay. We are gonna add a rectangle right here. Okay, so this should be on the rectangle, on the X axis, this point, and we want it to be exactly here. So again, the distance from here to here is going to be the tackle box total width, and the distance between here and here is the lid depth. So this is gonna be the lid params dot total depth, was it? I think, yeah. And now we need to constrain this line, which is the snaplock dot, what did we call this? What did we call this? Thickness, total thickness. So this is gonna be snaplock dot total thickness. Yeah. And now we can pad this. This is the correct direction. And it's gonna be the width, no, hinge width. Okay, there's something wrong. Yeah, because we're using thickness, but it's actually hinge width. Okay, now we should, let's see. So the distance between, come on, FreeCAD. Okay, the distance between this line and this line should be 10 plus 2 tolerances, so 10.4. So let's do that. Let's calculate this. Starting from this line to this line, it's 10.4. Great. And now we need to, let's clear this calculation. Let's reuse the array that we had earlier and pattern the pad to the other direction. Let's test this. So number of locks, let's set it to 3. So these should automatically update, and now we will have 3 lock hinges. We haven't done the lock yet, but these are going to be like the hinges for the lock. What else do we need to define? Let's see. So we can go to the body now, the box, and do the exact same thing, or we can start by doing this. Maybe I should show it to you. So we have this ball right here and right here, similar to what we did on the lid, but yeah, as you can see, there's a ball here. We can do the ball now. And yeah, let's do it. So let's come here and say the ball diameter. What did we use for the lid? Ball diameter 5. Let's go for 5. We can use the same values, but I'm keeping them separate just so they are more customizable. So let's go for 5. What else do we need? Ball. Was it offset? I think. Ball offset. And let's do it. Okay, so we still have the datum plane, right? Datum plane here somewhere. No, not this one. This one. Can probably attach something here. Or yeah, nah. Let's just, so here we need to cut a sphere, not add a sphere. So we're gonna go with the subtractive sphere. And let's see, if we don't attach it to anything, what's gonna happen? I think it's fine. It's gonna attach to the origin anyways, and now we can move it here. Let's change the radius. So this is gonna be the snaplock dot ball diameter, but it's a radius, so divided by 2. And now we need to move it here. So We don't need any reference, so then select anything. Oh, we have to select something. Okay. Let's start from this. So I'm gonna select this datum plane. And now we need to go in the Y direction. No, X direction. Yeah. So Y0 and X. Why can't I see it? So in the X direction, this way we need to go by the total width. So tackle box, the total width plus, so I want it to be in the center of this line. So this is gonna be the snap lock, the total thickness divided by 2. And it should be exactly in the center. Now we're gonna fix this thickness, give it a minimum value or something, so that the ball isn't bigger than it. It should always be smaller than this line. We can do that by minimum and maximum values. And now I want the ball here. So in the Z direction, in the negative Z direction, I need to go minus snaplock dot hinge width. And I also have an offset for the ball, so I need to remove the offset. Since this is negative, to remove it, we need to add the snaplock dot ball offset. And yeah, that's amazing. Click OK. Okay, there's something wrong. Wait. That's because it's on the x-axis, or sorry, on the y-axis, so we want to lift it up, and this is the y direction. The reason x, y, and z are different than the global x, y, and z is because we attached it to this plane right here. So it always assumes that the z-axis is perpendicular to the plane, and that's why so these are local. Yeah, it also says it here, local coordinates, not global. So in y direction, we need to, let's put it in the center. So this is going to be the lead total depth divided by 2. Let's hide the plane. And now we can pattern this. So I'm going to select this, the array, and pattern. Now we have it everywhere. Okay, let's fix the diameter being bigger than the width. So the total width, where is it in snaplock? The total thickness is gonna be thickness plus extra thickness. So thickness here. Okay, let's move this to here. This is thickness. Let's do another one. Thickness. And let's set this to the same value 4. And I'm gonna call this one thickness input. So this is what we will input, and then this is gonna be the actual value of the thickness. So what's gonna be the value? It's going to be equal to, we wanna set a minimum value. So to set a minimum value, you do max, and I'll explain why if it's confusing. Ball diameter, let's say we want at least 2 millimeters above and larger than the ball, so 1 millimeter on each side, and then we do thickness here. And why is this a minimum value? It's because, wait, there's something wrong. Ball diameter plus 2, what's wrong? I am off today. Thickness input, sorry. No, What did I do? Come on. Okay, now it should be fine. So now thickness is 7, even though we said that thickness is 4, but it's gonna be actually 7, and that's because it's gonna come here and says, okay, ball diameter plus 2, that's 7, and thickness input, that's 4. So what's the maximum value between these two? It's this, and that's why this is how to set a minimum value. If you want to set a maximum value, you use min instead of max. So now, as you can see, we have 1 mil from this side and 1 mil from that side. And we need to do the same for this one. So to do that, we need to go through same process. So subtractive sphere. Let's go to the top, see where we are. We are going to attach it to this plane, and in the x-axis we need to go by tackle box dot total width plus snap lock dot total thickness divided by 2, and now it should be in the middle, yeah. And let's set the diameter, ball diameter divided by 2, because it's a radius. What else do we need to do? We need to go up, and that is in the y direction. And how much do we go up? It's the lead params total depth divided by 2. And now we need to come in this direction, so in the z direction, positive direction, not negative. We need to go by snaplock dot hinge width, was it? Minus snaplock dot ball offset. And this is it. So now, again, we select the sphere, select the array, and pattern it. Let's test this real quick. So 2 snap lock, number of locks 2 instead of 3, and magic. Okay. And now we need to repeat all of this on the box. By the way, I was going through the subreddit for FreeCAD, and they are working on lots of improvements that will make like our process a lot easier, hopefully. Can't wait to get these updates. So how do we start? Let's see. I remember we had some planes, but these will not help us. So let's just go to the origin, and let's attach a plane to the XZ plane. And in the negative y direction, we need to go by tackle box dot, border radius minus snap lock dot what was it called? Spacing between locks. Yes. And click OK. So we can hide the origin now, we can hide this plane and create a sketch. Okay. So is this one bigger than the one above? No, should be. Do I have a height? I have a height. Interesting. So I need to respect that height. The height. So the height is gonna be basically the distance between this point and the point at the top, right? We can figure that out easily because we know the total what is it called? The total depth of the lid. We know there's a tolerance here in between them. And we know the total height, so we can just subtract it. But first, let me pin this here at the top. So I'm gonna select this and this, and we need the what? Select exactly one line or up to 2 points. Okay, let's do that again. This point and this point. This is the tackle box dot total depth. No. Interesting. Total height. Yeah, total height. What's going on? Why can't I select stuff? Okay. I was still in in the measure tool or the constraint. Oh, I'm so off today. Okay, now we can constrain this horizontally. So we can select, for example, this point and do the horizontal distance. And this is gonna be the tackle box dot total width. Okay, and we know this width here. This is the snap lock dot total thickness, and we are on the, all what is left is this basically. So let's see. This line right here has a height of snap lock dot height minus, we need to remove from it the lid height, or is it the lid height? Because okay, wait, clear, cancel, close, because the lock is gonna start somewhere from here. It's not gonna start at the top, so we need to we have extra thickness. Extra thickness is how much away from the ball. Okay, so we have 1 mil above the ball. So this is where the snap starts. And then it's gonna end somewhere here. So we need the distance from here. So this is gonna be, okay, so the ball is at the center. And we have this total height. So if we divide the total height by 2, we're gonna get the center. And then if we go up by radius, and then we can go up by 1, and we will have the distance from basically the top of this to this line right here. So let's do that. Go back to the sketch. So the height here, maybe I should do it in the snap lock in the spreadsheet, because I need to use it multiple times. What do we call this? So height in lid. So how much height do we have in the lid basically? This is gonna be so this is gonna be equal to lid params dot total depth divided by 2. We reach the center of the circle, and then we add to it the diameter divided by 2 because we need to add the radius, and then we add the extra thickness. And this is the height of the snap in the lid, basically. Okay, so we have this height and we have some offset here, some tolerance here. We need to remove from the total height. So this is gonna be snaplog.height. This is the total height minus the tackle box dot, oh, come on, dot tolerance. Yes. So this is the tolerance in between them. Minus the snaplock dot height in lid. We end up with 2, and that's because the depth here is, so we need to increase the height. Let's do 20 or even more. Let's do 25. Now the issue with FreeCAD, the current version, is that it will not update unless I close the sketch. This is like a known issue or something. We should probably have a minimum value for this, but I don't want to make this a very long stream. So let's just pad it. And how much do we want to pad it is the hinge width. And we can reverse it. Okay. And now we need to create basically the same array that we had at the top. So let's do that real quick. Lattice 2 workbench, create a new array. Direction 1 0. So we need it on the Y only, so just 1 on the Y. Placement position x-axis, so we need to go this way by tackle box dot total width. Okay, and now we need to go up by, interesting. Oh, we can just, actually we don't need to, in terms of like the Z distance, we don't need to be exactly in the center of this, so I can go here to the top. That's fine. You'll see it's gonna work. So in the Z, we need to go by tackle box dot total height, and in the Y-axis, we need to go by first the border radius. So now we're here at this line, and then we need to go by the spacing, or sorry, the snap lock dot spacing between locks. Remember, this spacing is even, so this is equal to this is equal to this, because we took the entire width from this line to this line and divided it by the locks, basically. Okay. And this is going to be a step and generator. So for here, for example, for each 50 meter, it will put one item, and it's going to put a total of 5. So the total is going to be the number of locks. So 2 in our case, and the step is going to be the snap lock dot total lock width plus sorry, plus spacing between locks. Okay, and now I can take this pad and this array and pattern them. Should work fine. Hinge width, number of locks 3. Yeah. Okay. Do we still have this datum plane? Yeah. Let's do the sphere. So as a reference, I'm gonna select the datum plane. Where is it now? It's here. So we need to move it here. This is Z, no, X direction. So much repeating stuff. But this is how you can get fully parametric models. So this will never break. Of course, unless you don't add minimum and maximum values, it might break, but where are we? Yeah, snaplock dot total thickness divided by 2, and the radius is snaplock dot diameter divided by 2, and now we want it here. So y, no, this is going to be the hinge width. Is it negative? I think it was negative, right? Yeah, negative. And then we have a plus, because we want to remove from the negative ball offset, and we need to lift it. By how much do we want to lift it? In the y direction, we want to go by the tackle box dot total height minus, oh, how much was this? And do we even need a ball here? We need a cylinder. Apparently this uses a cylinder. Okay, you know what? Let's leave it, that's fine. So the total height, we're now here. I'm gonna leave it as a ball and we'll fix it later. So we're now here. I wanna go down by, how much do we go down? Let's go the same way we did, basically the same distance we went up here. So this is gonna be the lid params dot total depth divided by 2. Let's do that and we'll change it in a bit. Yeah, same thing. I'm gonna click the linear array, pattern it. Now we need to do it one more time. So let's create a datum plane, attach it to this plane in the Z direction. We need to go by so tackle no snaplock dot spacing no total lock width, and I should be, this is negative, should be right here. Okay, I really need to know how can we where is it? How can we clone a sketch and move it? Because apparently we can't. Let's see, can we do that in the draft workbench? Like if I clone this sketch, the problem is it will not be in our body. It's gonna be outside. Can I move it inside the body? No. No, it doesn't work. And if I do a what is it? A shape binder, I cannot move that. so it doesn't have a placement. And what is the sub shape binder? Can we move it? Wait, we can move it? Interesting. Okay. Let's see. So I want to move it by the snap block dot what is it? The hinge width. So let's move it by the total lock width minus, or just the total lock width. That's fine. Should be right here. Yeah. So I don't need this plane. I'm gonna delete it. Let's see. Can I pad this? Yeah, it works. Snap block dot hinge width reverse. Okay. Yeah, that worked. Let's see if it's gonna break when we change something. So if I go here and change the number of locks to 2, no, it works fine. Interesting. I wasted so many time redoing a sketch because I was trying to use the shape binder, and I could have easily done it with a sub object shape binder, whatever that means. Just a second. Okay. But there's no shortcut for the sphere. Where is the sphere? Okay, we need to attach it to something, right? It was, where was it? This plane, yeah. So let's create a sphere, attach it to this plane. And where is it? It's down here. So in the X direction, it's going to be the total width, not the snap block, it's the tackle block. The total width plus the snap block dot total thickness divided by 2, and the radius is so many repeating steps. I can't wait for this project to be done. I want to do something different. Okay, so now we're here. We want it to be here. So in the Z direction, we need to go in the negative direction by snap lock dot total lock width. And then we need to remove from it. So plus snap lock dot hinge width. It should be exactly in position. And this one was the tackle box dot total height minus the lid params dot, what was it? The total depth divided by 2, if I remember correctly. Yeah, and I forgot something. Which direction was it? Z. Yes. So here I need to remove the snap block. We had a ball offset. Yeah. Yeah, it should offset a bit towards the back. Did we do it here? I think we didn't. Let's check this real quick. Oh, we did. In the Z direction, yeah, we did. We did. So now let's pattern this again. We're gonna have it on all of them. Okay. So that was one thing. And we still have to do the triangle shape here and here. But first, the hinge width or the width is too low. We need a minimum value for this, I think. Let's say 15. Let me think for a moment. I need a cigarette for that. And we can actually, we can start modeling. Let's create a new body. We can start modeling our snap. So I want to move the body up here. So if we show this at the moment, the body origin is down here, so we can move it in the placement similar to what we were doing previously. So this is going to be the tackle box dot total width, if I can type it. And in the Y direction, it is the tackle box dot border radius plus snap lock dot spacing between locks. And now we're at this line and I want to go to the middle. So that will be the snap lock dot total lock width divided by 2. And now I'm exactly in the middle. I want to move it up. And where do we want to start it? It's usually at the end, to the end. Okay. So we want to start it from this line right here. So in the Z direction, tackle box dot total height minus snaplock dot height in lead minus tackle box dot tolerance. I think it should be like that. No, this is not it. Height in lead should be it. Let's go here to where we was it this? Okay, it was this. Total height, no, not this one. The distance between this point and this was what? We called this, okay, this was the height minus, so the height is the height of the snap. So it's the height of, whoops, sorry. It's the height of this. Yeah. Okay, now I know what to do. So here, okay, let's go back to this body. In the Z, what we need to remove from this is the, so this is minus here, and here we need to do the snap lock dot height. And now it should be exactly on this line. Great. So now we're in the middle of the lock at the bottom. Let's hide the origin, or let's keep the origin because I want to create a sketch on the YZ plane. Now we can hide the origin. Okay. So now I want to draw this shape like that. So this is the bottom and this is the top. Let's do that. I'm gonna start with a rectangle and then we can start adding stuff. So something like this. So this is our height. Whoops, sorry. Yeah. Oh, by the way, I want this to be centered. So how do I say this? So this is the center point. I want it to be symmetric, basically. So if I click this point, and then at the end click this line, we can have the constraint symmetrical. And now this was always symmetric. So all I need to do now is define the width, which is the width of the snap lock. So snap lock dot width. I should have a bit of tolerance here. Yeah, that's great. Excellent. Okay. And I think I forgot to do something. So when I created these holes, I didn't add tolerance to them, but we'll fix this. That's fine. Okay, we're not done here actually. We need to create some sort of a triangle here. We can do that right. Yeah, it has to be right in the center. So, let's draw a line from here to here and the line from here to here. So we want this to be exactly in the center right here. And how do we do that? We can define the distance, the vertical distance from the origin up here. And this vertical distance will be equal to the snaplock.height, the total height, minus the snaplock.height in lead. This is the height from here to the beginning of the lead. And then I want it to be in the middle of the tolerance. So this is going to be the tackle box.tolerance divided by 2. And it should be exactly in the center. It cannot move up and down. And I want these two to be symmetric on this line. We don't have a line at the moment, but maybe we can create a line. Let's create a line from here to here, and it has to be horizontal. And this line is a construction geometry, so it won't be included in the sketch. And now I can go and select these 2 points and this line and mark them as symmetric. Okay. What else do we need to do? We need to Maybe, do we need to define it by angle? How do we define this? Probably by angle. But then getting the tolerance right is going to be tricky. Yeah, let's go by angle. I think we can I can figure it out. The tolerance thing. So constraint angle, and let's do this at 45. Yeah. And now all we have to do is basically define the width of this line. I think we should have this here somewhere. Let's call this triangle. What was the name? Hypotenuse or something? In a triangle, when you get, I don't know, triangle midline width. When you have too much stuff going on in a spreadsheet, it could start to lag a bit. As you can see, there is a small lag. It's fine though. Nothing, not like a really long lag, because, and I'll tell you what happened once. Just give me a moment. This is the snaplog dot triangle midline width. Okay, so when I was doing the fishing rod, the parametric fishing rod in FreeCAD, I didn't separate everything like into multiple spreadsheets. I have like one really big spreadsheet with every single parameter inside of it, and it was a nightmare. Okay, what happened? Yeah, so every time I needed to change a simple value, I have to wait like minutes. Not sure what's happening with FreeCAD. I saved just in case it crashed. Now we need to trim this line here. So trim, remove it, and what happened? Let's see. Interesting. Okay, the problem is, what is this? Let's take this point and this point and constrain. The angle was gone? No, it's still here. Oh, okay, so now this point is moving. So we need to select this point and make them vertical. But what is wrong now? Oh, come on. You and this line should be symmetric. Yeah. Now it's working. Okay. So we need to do the same on this side. So let's grab the line. Okay. What's happening? Let me just be sure. Okay. Yeah. Okay. So I want these to be symmetric. So basically I just need to do this symmetric, this point and this point, and then the same for these two, symmetric, and the same for these two, symmetric. We can now trim this line here, and oh my god, what do we have now? Come on. Whoops. Okay. So this broke up a bit. Let me fix it. So these 2 points are coincident. Okay, we have one constraint missing. What is it? This one? Oh, okay, yeah. So these two are also coincident. Okay, now it's fine. Okay, what else do we need to do? Let's do this for now, and then we'll do the rest. We need to pad it. So how much do we pad it? It's the snaplog.thickness, was it? I think it was the thickness. Because this is the extra thickness that we added here. 1. So if I set this to 2, yeah, now we have more. Let's click OK. Set this back to 1. Whoops. Okay. So what else do we need to do? We have multiple things. We need to cut this line here. I don't know if you can see it. It should be, yeah, this small line. And what else? We need to model the triangles here, basically on the lid and on the box. Let's cut the line first, and then we can take this object and if we have, let's say, 3 logs, we need to pattern it, create an array, and pattern this log 3 times. So much stuff left. Okay, so this line starts from like right here, this point, like right here, it goes this way and then goes down. So we need the thickness for this. What do you call this? Snap thickness? Oh man, I'm just putting on some stupid names. Let's do 2 mil. If I'm gonna release this file, the FreeCAD file, I'm gonna have to rename everything to something that makes sense. Okay. So how do we... Oh, come on, I'm just trying to click off. Yeah, to deselect everything. So how do we know where this ends? That's the question. We can probably throw this point again and then go 45 degrees with this line. Yeah, and then we can cut. Let's try. So another sketch, also on the same plane. We want to cut from here, somewhere here. Okay, wait. We need to toggle this, yeah. This has to be horizontal. And we need another line, some like that. And then this will go all the way down. Till we'll define this, the distance from here to here in a bit. But we need to first define the starting point. And we already know that the distance between these two is snaplog dot, or no, wait. The thickness is actually the distance between the start here and this line. This is gonna be the cut. Let's call this snap cut width. Let's do a 1 mil for the cut width. Okay. So the distance between these two is, oh no, I have to go here. Snap block dot snap cut width. And the same between these two. The distance between this and this. Dot snap cut width. Okay. At the end, these two are gonna be on the same. Whoops. Gonna be on the same horizontal axis. Okay, now we need to define the thickness, and we need to also start from here. And these two are also vertical. We need to connect them. So it's important that the sketch is closed. It has to be closed. Okay, let's start by defining this point right here. So the distance between this point at and the origin is the snap block dot width divided by 2, and this is gonna start exactly here, but I want to move it a bit more, so I want to start from the outside. Let's add a snap block dot tolerance. So I'm gonna start from here basically. And now where do we start from in terms of the vertical location? I'm thinking about, yeah, I need this. I need this line right here. So the only way to do that is I'm gonna add a point here, and I need to define it. So let's do that. The distance from here to here is going to be, how much was it? The snap block dot height minus snap block dot height in lead minus snap block, or no, not snap blocks, tackle box dot tolerance divided by 2. Oh my god, I'm losing my voice. Yeah, I'm way off today. I should probably rest in a bit. Okay, now we don't actually know the horizontal distance, or do we? I think we do. Yeah, midline width. So this is the distance between this and this line right here. So we can do that, something like this. Snap block dot midline width plus the tolerance, because we're outside this line by a tolerance. So now we're exactly at that point. And now to get this line, we need to draw it, and we need to define the angle. So the angle is 40, it was 45 exactly. And now we need to define this. So the horizontal distance between this and this is 0.2. We know that because it's the tolerance. Okay, and this is construction, of course. construction. And do we need to mark the point as construction? I think so, yeah. Okay, so now distance here is how much do we want to make it? Let's do the thickness, snap thickness, and also the distance from here to here is the snap, oops, snap log dot snap thickness. Yeah. So the only thing missing is this. And to be honest, I'm just gonna set it to 3. Too tired to add it to the spreadsheet. And now we need to do everything on this side, but I think we can mirror it. Wait, so if I close and I pocket this, let's go reversed. Let's see, yeah, something like this. We can actually go through all and click OK. And now we can click this and mirror it on the XC plane. Okay. Yeah. Now it's starting to look like this, just a bit taller. So let's make it wider. The width, let's do 20. Yeah. And do we need to do anything else here? Yeah, we need to do something. We still need to add the balls, 2 balls, and then we need to add a cylinder here, or we can just make it another ball. So let's do that. I'm guessing we can, we do an additive sphere, and this sphere is going to be the snap log dot diameter divided by 2. Again, there's gonna be a tolerance, but I forgot to add it in the hole itself, so I'll fix that in a bit. But for now, let's attach it to the X, Y, X. It doesn't matter, to be honest, because we can move it. Okay, so the Z direction now is a bit weird. Y is up. Yeah, Y is up. So how much up do we want to go? Interesting. What was the height in lead? It's the total depth divided by 2 plus the extra thickness. Small diameter divided by 2. Okay, what happened? What did I do? Okay, sorry. The extra thickness basically is up here between this and this. Okay, so the distance between these two is extra thickness. So if I go up by, yeah. So let's do this again. Let's attach it to the XY plane this time. Divided by 2. Yeah, so in the Z, now the Z should go up. Exactly. So how much do we want to go up? We want to go up by snaplock.height. So now we should be at the top, but we want to remove minus snaplock.extra thickness. And we also want to remove snaplock.ball diameter divided by 2. And to see it, we need to move it in the y direction. Let's see. Yeah, it's right here. So where do we want to move it in the y direction? It's minus snaplock.width divided by 2. Now it's here, but remember there's a there was an offset, ball offset. Okay, there's something wrong, and that's because in the x direction we need to move it this way, which is positive, yeah, which is the snaplock dot what thickness divided by 2. Click OK. So let's mirror this. We are going to mirror it on the XY plane. One transformation does not intersect support. What? Why? Base XZ plane, not. Why did it do it on the XY plane? I don't know. Okay, now it's fine. Now the question is, can we mirror this downwards? But then we need the plane and let's see. I'm gonna try something. I'm gonna create a datum plane and I'm gonna attach it to the XY plane, and I want to move it exactly in the center. So we need to go. Is it the Z direction? Yeah. And this is going to be, again, we need to do some calculation. So it's going to be the height minus snaplock dot height in lead minus tackle box dot tolerance divided by 2. Now we're dead center. So can we mirror this using select reference using this plane? No, we cannot. Only additive and subtractive features can be transformed. So basically it's telling me you cannot mirror a mirror. Okay, that is fine. We can just redo it. So create a sphere, attach it to the XY plane. In the X direction, we need to go by snaplock dot thickness divided by 2. This is going to be snaplock dot ball diameter divided by 2. In the Y direction, this is going to be, in the Y direction is going to be the snaplock dot width divided by 2 minus snaplock dot ball offset. And it's negative. That's fine. Let's do it here and then we will mirror it. In the Z direction. Interesting. We did it by half. Was it the lid? Wait. Let me test something. the total depth divided by 2. No, that's not it, because it was starting from here downwards. It was total width divided by 2. So that is going to be snaplock dot height minus snaplock dot height in lid minus tackle box dot tolerance divided by 2. Hopefully this will work. Minus lid params dot total depth divided by 2. Let's see. Is it? Yeah, I think no. Something is wrong. Wait. What did I remove here? Oh. Minus tolerance. Yeah. Not divided by 2. So tolerance divided by 2 will be in the middle. In the middle. I wanted to start from here and then remove the thing. Oh, come on. What did I click? Oh, okay. I attached it to a line. Never mind. Oh, I should have added the sphere before we cut the... Oh, man. Okay, we need to... Where is that cut? It's this, right? No, it was a pocket. Oh, not here. We're in this body. Okay, this is the pocket. We need to remove the pocket. Okay, yes. And now we are... Huh. Interesting. Show me the mirrored. I deleted the pocket. So the original is pad 11. Pad 11. Okay, this is the sphere. This is the mirror. This is the sphere now here. Now we can do the pocket. Wait, did we mirror? Oh no, we don't need this mirror. So I need to remove this mirror. Now the sphere is going to be added and mirrored and another sphere. Okay. Okay, now I need to mirror this sphere first on the YZ plane. No, XZ plane, sorry. Yeah. Okay. So now we have the mirror. Now we need to take this sketch and pocket it in the reverse direction through all. Okay, and now I can take this pocket and mirror it. Yeah. That is it. This should be done. So no more things to add to this. Let's call this a snap. Okay, and let me show you now how we can array an object, basically, not a feature. So if we go to Lattice 2 Workbench, and I think for this we don't need the snap to be selected to be active, so I'm gonna remove it. Yeah, it's no longer active, because if the snap is active and you create an array, the array will be inside of the body, but we want it outside. And now we need to move it to place again. So dir y0. So this is going to be a bit different than when you for example do a pocket or something and then use the array. And we use for that, we use in the part design something called part design pattern, lattice part design pattern, or you can also find it here, lattice part design pattern. But we're going to use something else called populate with copies. And this is when you have one body and you want to make multiple copies of it. And this requires a placement that we'll get to in a bit. So position, placement, position in the x-axis. We are going to go by snaplock dot, not snaplock, tacklebox dot total width. And now we're here, but should we go to the center? Let's go to the center. So the center of this is going to be snaplock dot thick. Not thick, thickness. Okay, in the y, let's do the z first. Let's go all the way up. So it's tacklebox dot total height plus we have some tolerance between them, so tolerance plus snaplock dot height and lid. And now we're exactly at this face right here. And in the y direction, I'm going to go by how much do you want to go? Tacklebox dot border radius, not recorder, it's tacklebox. So now we're at this line plus snaplock dot spacing between locks. Now we're at this line, and now I need to go to the middle of it, so that's going to be snaplock dot total lock width divided by 2. Fail to parse because this is a plus. Yes. Okay. And this is going to be a step n, and the step is the snaplock dot total lock width plus snaplock dot spacing between locks, and the count is going to be snaplock dot number of locks. Okay, so now how do we take this and populate it with copies? So if I just click the snap, control click the array and click populate with copies, it will be somewhere here. Because it does not know basically where this object starts or how is it oriented. In part design, it already knows that because you're working inside the body and you already have like an origin and stuff, and everything is known where it is. But outside part design, it's a bit different. So how will Lattice Workbench know how to populate this array with this body? You need a placement. So there are multiple ways to do it. You can do a custom placement and move it around, or you can, for example, attach a placement to this face, for example, XY on plane, and then where is it? Let me hide the array for a bit. Placement, it's not visible for some reason. Let's hide the lid. Okay, so what happened here? Okay, let me delete this and this. Okay. So we selected this face, but for some reason it's here. Interesting. Anyways, I'm not gonna do that. I don't like selecting faces because of the typological naming issue in FreeCAD. So we're gonna create a custom one. So just create a placement, and now we need to move it. So first let's rotate it. So we want it on the Y axis. I think it's this one. Is it? No. What's going on here? We can do an angle like 90-degree probably. And now we need to move it this way. In the x-axis again, this boring stuff. Snaplog dot. So basically we want to get this placement at the first like right here. So snaplog dot not snaplog, tacklebox dot total width. It doesn't have to be at the first one, but it has to be somewhere on this. And I'll show you in a bit. I'll show you what will happen if we rotate it and what will happen if we leave it as it is. So total width plus snaplock dot thickness divided by 2 in the Y. Wait, just oh, come on, I cannot. You're kidding me. Oh, placement, okay. I thought I cannot label, flip that. Where is the angle? So angle here is 90. Okay. In the Y, we need to go by tacklebox dot border radius plus snaplock dot spacing between locks plus snap lock, if I can type, dot total lock width divided by 2. Okay, and now we need to go in the Z direction, which I remember was tacklebox dot total height plus tacklebox dot tolerance plus snaplock dot height and lead. There's a difference here. It's in the Y direction. I don't need to do this, but divide this by 2 apparently. Oh no, not in the Y, it's in the X. Sorry. Okay, now we're on the same placement. So now if I select the snap, then I select the placement, and then I select the array, should theoretically work. But it didn't. Wait. Oh wait, no, it was the snap, then the placement, then the array, then we need to select move object. Okay, yeah, moved object. So now we can hide the snap and we can hide these two, and we get this moved snap. And this is parametric, so if I go here and change the number of locks to 2, yeah, this is gonna update. And this placement is very important. So if I take this and change the angle to 0, for example, it's gonna set them in this direction. So if you modeled something, for example, and you modeled it in the wrong orientation, and then you wanna take this model, you don't have to model it like right here. You can model it down here, and then all you need to do is put the placement on the model down there, and then put the array up here, this array, and let's revert this back. And then you can like populate this array with copies of this model snap. So let's revert this back to three locks. It's gonna take a couple of seconds, no more. And that's it for today. It's already 11:30, and to be honest, I'm not feeling very well today. I'm a bit sick, so I'm gonna have to go rest. But overall, we're done. We just need to do some cleanup. Like for example, this ball right here, we need to add a channel for them. I don't know if it's visible, but let me show you what I mean. So on this thing, there's like a channel between like the ball and the end. So this is a place where you can where is it, press fit it, something like that. So it goes from the top, and then you rotate it somehow, it fits. We need to add these channels. I need to add the triangles here on the lid and the body. And overall, I think that's it. We can do some other stuff, like let's hide the snaps. We can add sections here, more sections. But yeah, for today, that's it. And I'm not sure if I'm gonna continue in next week's episode. I'm not sure if I'm gonna continue with the same project or we're gonna start a new one, because to be honest, this is already 3 live streams and it's kind of done. So I might do these changes in the next couple of days and just upload the files to printables. Probably do that, and then next Monday we can do something different, something new. But it was a nice project. We learned about the Lattice 2 workbench. We worked with part design. We worked with spreadsheets. So yeah, I think it was a good project and a useful one, because I'm definitely gonna print this and use it myself. Yeah, so that's it. Thank you for watching. If you have any questions, any suggestions of projects that you want to see me build, don't forget to join my Discord server. It's down there in the description. And yeah, see you in the next video or next live stream. Bye.